झालं. दिसतंय ना? दिसतंय ना? याला युट्यूबला का? मला आता मीट जॉईन करायची का? युट्यूबला join. तुम्हाला इथे यावं लागेल बोलण्यासाठी. माझं माईक सुरू आहे ना? कुठे? इकडं. सुरूच आहे mic.
आवाज येतोय? So today we are having webinar on image processing.
रंगला गेला ना माझा याला पण चार्जिंग लागणार आहे. 55% चार्ज आहे. सुरू झाले का? बोल लावून मी टाकलं. मला तुम्ही जॉईन करायचं का? मला इथे यावं लागेल. काय करायचं?
आवाज येतोय?
After some time, right? Yeah.
Then
स्क्रीन छान दिसली. स्क्रीन चांगली दिसते. लाईव्ह आहे असं टाकून द्या. PPT. PPT कोण शेअर करेल? केलं ना.
So I welcome Professor Vipin Kamli and all other participants who have joined, and we will start in 5 minutes.
YouTubeला.
Please don't leave the session or leave station, and we will be starting sometime.
याचा आवाज काय आहे? आवाज नाही येत. Okay.
करेंगे ब्लूटूथ लगा के
So, very pleasant good morning to one and all present here. I, Shahnawaz Sayyed, a student of second year Information Technology Department, and all the staff and students of GH Raisoni Institute of Business Management Tilno, welcomes you all for this wonderful session on the topic techniques of image processing and role in machine learning. GH Raisoni GH Raisoni Institute of Business Management Tilno is always ahead in next series only, we are having one more such informative and skills upgrading session today. Also, I'm very happy to share that our today's session is going to be a national level webinar because we are not only having participants from Maharashtra but from various other states also. Really, a thing to be appreciated. My heartfelt thanks to Mrs. Preeti Agarwal, Director CHRIP, and Mr. Nitish Sinha, Team Academics, CHRIPF, for their guidance and encouragement in all our efforts. Now, in this series, I would like to request Mrs. Sonal Patil Ma'am, Head of Computer Science and IT Department,
Thank you, Shanava. So, very good morning to one and all gathered over here. We are very pleased to announce that in this semester, last year we have completed business activities. CSE-IT business management is an autonomous area and autonomous affiliation with the which is having and we are always upgrading, arranging such webinars so that we are always having students on the reputed institutes and degree. We always focus on businesses activities of the institution. And today's event is one of the events where we want to upgrade our as well as our knowledge in the image processing is very much because image processing is we can say it is part of our daily life because we all are on social media. Without image everyone on the social media. Without image we can't exist. So that's why definitely we should know what is important, how it works out, etc. So I'm very much thankful to Dr. Pradeep for accepting our invitation and as well as I would like to appreciate our students. I will appreciate the team. The team is really hard and they are working 24/7 and we are very pleased to announce that this whole event will be organized and managed by our CSI team. So the special thanks and appreciation goes to the team as well. Again, in next month we are coming with SPP and business roadmap. Instagram page and we are having our YouTube channel Instagram page and you can message us throughout the that so that all the updates so I am thankful for accepting the invitation. I am thankful once again for accepting director of director of for his leadership and vision. I am thankful for his leadership and vision for your leadership and vision for always guiding us and for showing us the right path. I am thankful to Dr. Nitish Sinha for his continuous support and vision. So thank you everyone and thank you Shanavas for giving me this
Thank you, Shanawaz, for giving me this opportunity. My pleasure, ma'am. And we would really appreciate after hearing your words. And this session will definitely prove worth of attending. And the participants will gain some knowledge in the particular field. Okay, so now I would like to introduce our today's resource person who is based for Institute of Technology, Nagpur, and is now working as an assistant professor in electronics and communication engineering department at Indian Institute of Information Technology, Nagpur. His expertise in image quality assessment, image noise estimation, and image denoising. He has done various publications including no reference noise estimation in digital images using random conditional selection and sampling Modern videos is main learning technique for image
Uh, sir, just a second, I would like to interrupt. I, yes. Sir, just a second. Yes, sir, just a second. Open, sir. Yeah. So I would like, I'm very happy to share that I'm very happy to share that this is a national level webinar because we are having entries from not only Maharashtra but from Gujarat, Madhya Pradesh, Uttar Pradesh, Delhi, Haryana, and so on. So we are very happy that we have received a very tremendous response to this particular session, and because of that we are on our channel also. So the live session is also going on our participation is very higher. So the participation is very high. So the topic is so interesting that the response is very high. So thank you and over to you, sir. So, and the particular yes, sir. अरे वाह.
just have the image. You have created a sustainable form. But it, like you're turning this picture of your head. So, yeah, why not? Black and white. That's right. But I'm the lights per pixel. That, this is why. So something in that what you'll see three colors and so here how much for each pixel you require 3 bytes and there are 16 multiplied by 3 you will have 48 megabytes of data corresponding to a single image which is of 16 megabytes. But if you observe, even now you can try the mobile phone display, you can capture any image from your surrounding of any resolution and try to find out what is the size. Just you have to open it in gallery, go in details and check. The file size will be more than 5 megabytes. Okay, capture an image of intelligence they would have been 48 megabytes. Effectively on the disk you are getting size of around 5 megabits, which is 180%. And mostly I would recommend any of my PhD students also to work in image compression because uh, there are it is a commercial topic and as like the commercial companies is very high. So you have to compete against a big team to surpass the results. And nowadays it's very social. So to surpass the existing results is a difficult. So again, one of the basis the reverse of what you did for compression. So again, one of the interesting topics, but not recommended for research. So from image processing, as you have a fair idea that yes, what exactly is image processing, then shift the computer graphics. Okay, what is it? Also two-dimensional data.
Glorify.
And on that is because that on that get the different view that takes. Okay, so to compute light interaction and projections, this connect a 3D geometry data to two-dimensional data. Basically, the of 3D image. This is a good image. After you have computer vision, which is of very much important nowadays because here exactly opposite is happening as compared to computer graphics. You have a 2D image, and from 2D image, it is possible to construct 3D geometry data. So let's say that how come you're getting data? If data is not there in production, how are we generating that data? So for that, we are taking help of machine intelligence. That's where today's talk will come into picture. That yes, you have to have an image from image and that what is that is there. You know, so that what is size of one nose or length of shoulder. All these things are in proportion. that can be learned to a model, and from that model one can interpret exactly what is the age of the human, what is the gender, what can be the nationality, or even recently I started working on sentiment analysis, means you give a facial image and the algorithm will put or any conscious just from the face. Okay, so that all in raw two dimensions, or you can also have 3D geometric data. That is your computer vision. And in robotic vision applications, you have whatever we have seen till now, the computer vision application in robotics, specifically you have in self-driving car in India, but in USA, once your machine and it's very independent driving mechanism. So like autonomous robot navigation, inspection and assembly, all these things can be included in robotic vision. And most importantly, you have pattern recognition. That effect try to return vertical, horizontal, rotated in any pattern. We are able to the letter A. Okay. This will started exactly sometimes apples are present with the through your method. We try to match the pattern. So it is different and many classical only it is stable because we require very good quality images. And that's why it has triggered much of the research which has led to today's field of computer vision. So basically, computer vision has started or emerged from pattern recognition. So the roots of computer vision, you can say, they were planted in 1960. We were not having, you can say, required technology because even the images that were captured cameras. Nowadays, you have to check film or the video. You have to clean the film, send it for production, and then you can see what exactly was captured. It started, the mathematical foundation was laid down, but its application was not. That principles are now also extremely extensively used in computer vision. So from computer vision, you have your artificial intelligence because once you give vision to a computer, it should be intelligent enough to recognize or take decisions on its own. So it is concerned with designing systems that are intelligent and also studying computational aspects of intelligence. So it is used to analyze scenes by computing a symbolic representation of the scene. So currently, if you are looking at this lecture from your laptop, let's say, so you can see that yes, at the center, some letters are written. Your computer can extract information from that letter, like it is checks it is find that yes, artificial intelligence is written at the top. It can at the back end do a search that what exactly is the meaning of this artificial intelligence. It will do all the grooming part and give you the result. Okay, so many techniques from artificial intelligence play an important role in many aspects of computer vision, and this computer vision can be considered as a subfield of computer artificial intelligence. So one might say that yes, everyone should work in computer vision, but the field, though not new, but slightly difficult as compared to basic image processing because it is a many to one mapping. What I mean by many to one mapping is
A variety of surfaces with different materials or different geometrical properties and even possibly different lighting conditions can lead to identical images. So, n number of objects, illumination conditions, material, shapes, if taken, if observed from very close, you might find that oh, everything looks same. And also, inverse mapping is not a unique solution because many things are being mapped to a single value, and in this case, inverse mapping becomes slight difficult task. Also, as we are dealing with 3D object data, it is computationally intensive. So we cannot understand the recognition problem so easily in computer vision. Okay. So the practical considerations that one needs to see are the constraints that are imposed to recover the scene. Because to recover any information or any data, you require more similar data or more images related to that. And also, there should be third count on the constraints of your real world scenarios. Along with that, you have the limitation of computability and robustness. Also, you have to check whether the solution is computable using reasonable resources. Because if I give you an image and ask you to determine what is present in an image, but if the algorithm is designed such that it is taking 1 hour or 2 hours to determine what is there present in an image, definitely the algorithm is of no use to us because it is not able to give the output in real time or not even in this acceptable amount of time. And industrial computer vision systems, they work well because they use very strong lighting conditions. The objects are positioned properly, and the objects are categorized beforehand. Okay, so this is an industrial computer vision system in which we are trying to recognize which object is there. So you can see that a illumination bulb is present, which will ensure that sufficient lighting is there. But when we take the normal images or shoot a video, we don't bother about these things. So for industrial application, image acquisition system consists of the illumination parameter also, and there is a strong, you can say, computational capability which is attached to this system, which will give us robust results. So there are three level processing, like the basic low level processing in which the standard procedures are applied to improve image quality. It was one of my topic of research, and the procedures are required to have low intelligence capabilities, like to have an image, go for image acquisition, processing, then you can have segmentation, representation, description, and finally recognition and interpretation, which will give you the result. So in low level processing, you only need to capture the image and do a small amount of pre-processing. Let's say remove the minor noise that might be present, especially the uh, sensor dependent noise like poison noise, which might be present. So this is the low level processing, which comes under image processing. Then intermediate level processing in which you extract and characterize components in the image. So some intelligent capability is required for that. Like on the left side, you can see that the image consists of one house and two trees are there. One in foreground and another is background. If you only go for edge detection, you get some form of edges, like the one on the right hand side. But from the edges, can the computer interpret anything? Will it be able to understand that what exactly is present in front of it from the edges? A human observer will be able to do it. So for that, the third level processing is there, is recognition and interpretation. Basically, you have to label multiple things. Using multiple things means you have a house, e roof, because house consists of your roof, windows, walls, doors. Okay, so there exist algorithms which does this job like sky, tree, roof, right? This you might have also observed like the front facing camera of your mobile phones. It will take very good photos of your face because it first recognizes whether face is there. As soon as it recognizes face is there, in the facial region, it will enhance certain parameters like some brightness or contrast just to make sure that yes, the face looks better because as a human observer, we are interested even yes, how our faces look like. If you go for even group selfies, one tries to find out his or her face and just checks whether whether my eyes were closed or not, how was I looking, whether there was reflection from my glasses. So for that, first recognition of faces is foremost important. Similarly, that comes under high level processing. So if you give any image, the algorithm should be able to determine what is there, like garage, roof, sides, bushes, and if how many houses are there. So in previous image, if when from my side and is at this, but at the back side, if you observe, there is similar structure to a house in this part that can be categorized, like the things that can be reached by human eyes, specifically because human eyes focus only on what is present in the foreground as compared to what is present in the background. Okay, so all these things are possible because of your machine intelligence, extracting roof or extracting what exactly is present in image. Now one might say, why to do so much jugglery? जैसी image है वैसे रहने दो. Let's why to invest so much effort just to determine what exactly is there in the image? So uh, after lecture, you can search. In China, they have implemented a large-scale face recognition system, and the government knows exactly which person is going where, what are their intentions, and at each square, a face recognition system is there, which keeps track of person. Like even in Nagpur, where I stay, we have a visual system of cameras in almost every square of Nagpur, where even they haven't implemented it, but it is possible to send challan to person because the number plate recognition system and all those things are already integrated as a part of that surveillance system. But face recognition is not there. But if you are able to automatically recognize, like best example can be if you know that in the premises of your college an unknown person is there, as any of the student or faculty or member of that institute, no, the unknown person will have a particular characteristic that the person will look at left or right or try to analyze what is there in the premise. So detection or anomaly of such kind can be detected just by analyzing this video. Okay, so this field is of very much importance with respect to the security also, because you can go for it is actually called gate analysis, DAIT. In gate analysis, one can know that yes, whether a person is walking suspiciously or not, or how is its properties. Like a person who is walking confidently or the person who is in suspicious activity, both have slight difference in their walking mechanism. Okay, so this comes under the third level or high level processing, recognition and interpretation. This procedures require high intelligent capabilities that are possible through providing large number of learning data. Okay, so let me check cues. Like I have shown you one image. What can you interpret from this image? One might say that yes, it looks like the image of a hotel. The image is difficult to interpret for a computer because it will try to find that oh, there are lot many number of chairs and tables are there, but the uh, computer won't be able to determine what event is currently going on, because as a person we are used to this event that yes, some kind of decorum is there, so event is there where food is going to be served, so that is our interpretation, but a computer won't be able to interpret this because for it it's a bit of complex task. So again, in this image also, you can see that a small child is there in front, and at the background there is a painting. So as humans, we can easily, immediately we knew that the child is real and the background, the men sitting on horses are only in the form of painting. So for a computer, how will you tell the computer that what is reality and what is only picturization? Okay, so what knowledge we use to process this image? The basic knowledge of yes, we know how a painting looks like, and we also know how a child looks like. But nowadays, like you might have seen the science fiction movies in which the graphics are so good that you won't be able to recognize whether it is a real thing or a So like the role of color. So if I give you this object and ask you what is this object, you might be confused that whether it is a flower, whether it is plates. But this, if you give different color, it will be very easier to recognize. Okay, so these are the challenging tasks which are being faced by these computer vision applications. Now in this image, even if I provide a small part of the image, you will be easily able to recognize that yes, the image belongs to one of the members of cat family. It will be difficult. No, not even difficult because like from you can see that yes, it is cheetah, but the spots which are there on the screen they are different for jaguar, cheetah, leopard. Okay, so even if I give you a part of this image, from the texture itself, it is readily recognizable for a computer. But for a human observer, if I give a patch, you will be confused whether it is cheetah or a jaguar. Okay, so the role of texture is very much important in recognition. Now next image, a person is there who is swinging and that swing is I think attached to a tree. All this we are able to interpret only from the image or from the shadow of that person. But with a computer we are able to do that. And why we as humans were able to interpret this? Because since childhood we are accustomed to looking at shadows or how a shadow looks like if we are rotating hand or for each and every action we have seen that yes corresponding shadow is there. Okay, so our brain has learned so much of information regarding shadows that immediately we are able to discern that what exactly is present in this image. Now this is a easier task for humans. Another task, what is present in this image? If one looks closely it is image of a dog, but there are no sharp edges corresponding to the we can say skin of the dog. So where exactly is the dog? That the you can say structure of dog is constructed in our head. This is not possible in your computer because we as humans can easily interpret that yes there are two legs at the front side, one leg at back side is interpretable, face is interpretable. So all these things are possible only if you group particular number of spots which are present on the image. Okay. So for that, all these things require is you cannot simply do this by guesswork. You require basic mathematical foundation which will help you to do that. It is a computer vision. The vision systems employ simple heuristic methods. Today, the domain is heavily inclined towards theoretical, well-founded methods involving non-trivial mathematical solutions. And the basic mathematical things which are required are your calculus, linear algebra, probabilities and statistics play a very important role in that. Signal processing is required provided you are working in the sensor part of it. Projective geometry is the core required if you are working on the 3D models. Computational geometry is required if you are trying to interpret the 3D geometry data. And lastly, you require computation and control theory to optimize your algorithms. So there are various computer vision applications which are attached with this topic, which are like industrial inspection, quality control. So it's not that image processing is a very small topic. It is a very large topic, and nowadays with the advancement of technology, image processing and computer vision is present in almost each and every application. Like in previous semester, I was taking one online lecture, and I found out that there was one username which was not familiar. So I tried to search. I asked for no one answered. I searched that username on Google, and then I knew that it was a artificial intelligence based notes taker. The name was I think Firefly something. AI.Firefly. So what they do is whatever is the online lecture is going on, you just go add that the bot to that meeting or online lecture. The bot will automatically take notes for you. Okay, so that's the thing that nowadays the students are doing. Yes, we are. It's the use of technology. If it is shown on the screen, what are the words which are uttered, and also the Indian pronunciation for English is vastly different from the US or UK counterparts. Our pronunciation is not, you can say, well suited for the voice recognition system that is being deployed. So the system also has to depend on what is present on the screen to determine or to pick out all the notes. Okay, so there are multiple industrial applications which require inspection and quality control. Surveillance and security is a dedicated field for that. You have face recognition, gesture recognition, you have space-based application the biggest satellite, Hubble telescope, which is being deployed in space. The images captured by that Hubble telescope requires a lot of post-processing to give you a proper image. Then a dedicated field of medical image analysis there. It itself is a vast field because almost all of you might have visited an ophthalmologist to get your eyes checked. If you have seen, there is one machine which can give you directly what is the number of your eyes without even asking whether you are able to see the image in front of you clearly or not. That is the power of medical imaging. A very good center for medical imaging is there in Nanded, SGGS College. Their center of excellence is there for specifically for medical imaging. So if you happen to visit it is a must visit place to know about what exactly is going on in the medical imaging field. Then you have autonomous vehicles currently not present in India. Virtual reality is that if you go to the gaming zones of malls, there you might find that they'll give you one headgear, you wear it, and you'll feel that, oh, where I have landed. You will feel that you're in a totally different environment. That comes under your virtual reality. So, from visual inspection, what all things can you expect? A image is there at top left side. It is of, I think, a motherboard. So image is there, but are you able to identify what are the ICs which are there on board? Very difficult. You should be able to know that yes, what kind of IC or what is the processor, if there any FPGA board or not. So for that you'll have to you will be required to enhance the image. Okay, that enhancement is possible provided you have a specific set of data that how much enhancement is required. Like if you want to denoise the image, one has to know that how much noise is present in that image. Okay. Then comes the character recognition task. This is very similar to Google Translate. Nowadays, that Android application is that I have that. That you point it to a signboard written in, let's say, Marathi language, it will give you its real-time conversion in English or any other language that you want. Okay, but for that it requires the character recognition and character segmentation because in front of you, here it is written as demodulation. But for a computer, it has to first extract that yes, first letter is D, second is E, third is M, O, D, U, so on and so forth. So all this information needs to be processed for character recognition, and it's easy that yes, it is written by a computer, typed in by a computer. If you give a doctor's prescription to a character recognition algorithm, definitely there's a very less chance that it will be able to recognize what is written. But as a human or the pharmacist, where you take that prescription of doctor, he or she will be easily able to recognize that yes, which medicine is recommended by the doctor. Okay, so character recognition, though large advancement is already done in this field, but the handwritten text conversion is still a difficult task because the way of writing for each person differs. Like if I ask you to write demodulation, definitely some of you will write it in uppercase, some of you in lowercase, some of you will use cursive. So everyone's writing style is different, handwriting is different. In that scenario, how to recognize a character is a difficult task. And also, like if you are written with some different color, then again there will be the might of you that whether this D is separate, E is separate, M is separate, because alternate letters have different colors. So whether to consider it as next character or part of the same word. Then comes your document handling, in which In previous days, like if you sign a check, that signature was required to be cross verified. So for cross verification, if you observe that do they go for cross verification of signature? They try to find out how many number of horizontal and vertical intersections are present in the signature. That is constant because every time, even if you sign the document after 1 month, even though the signature looks same, but slight the size of character, size of signature, slight things might change, but still the bank accepts that yes, this signature belongs to you. Okay, so that is also taken care using computer vision applications. So for signature verification, like a certain name is there, like starting with R and S. Even if you try to, you can say, rewrite the signature, it won't come at the same place. Like it will have multiple versions. So these versions make a simple template which can be then matched with the signature template. There are other applications such as biometric, very booming field. Also, like biometric, one might say that pandemic is there, we are not supposed to touch any surface. So, research is going on image processing based fingerprint recognition because you have your also we have discussed that the camera is let's say 16 megapixels strong or even the front camera if you use it consists of 12 megapixels. So putting your thumb on a biometric sensor, if you take image of that, won't you able to see what are the lines present on your thumb? So without touching anything, this biometric is possible using your camera. So you can take this task as one of your projects for final year. That yes, fingerprint recognition, but using mobile camera, where you won't be requiring to touch any surface, and still the attendance, biometric attendance is possible. Then comes the iris scan, because for each person, the iris scan is unique, uniquely stamped. But again, iris scan requires one person to go very close to the machine. Okay, in a risk zone. You have ECG signal analysis. For each person, this ECG is also very specific. Face recognition might fail sometimes because in case of identical twins, the faces will look very similar. Like even you might have had friends which were identical twins, and it is difficult to identify them just by their face. But if you observe, their walking style might be different. There's the way they speak, their voice, they might be different. And also one more thing that is different is that heat map of their face. But like normal cameras won't be able to recognize that. But heat map is also a signature label for each and individual person. Then you have your this complete hand analysis. At last, the signature is there. So all these biometric things analysis are possible in image or computer vision itself without the use of even going into hardware. You require only one camera to do it. Or in case of ECG, you require the corresponding sensors. So, how does fingerprint verification identification? I will be only telling you the basic mechanism. I won't be going in the mathematical analysis of it. So, first, what you do is you require a data set. Means, in the initial stage, your biometric data will be saved in some data set. So, whenever next time you visit it, you place your thumb there and ask the data set that whether this thumb expression is matching with
आता का
anything present already present in the data set. If it says that yes, it is matching, then it's fine. But if it says that it is matching with 5-6%, then not a good way. Unless it gives a one-to-one match that yes, you have provided a fingerprint and it is matching with only one fingerprint which is stored in the data set, then yes, it will tell you that yes, the person is authorized to enter or the entry is made. Okay, so this is called a fingerprint verification and identification. You need to first load the data. We can call it as training data, and whenever you put that data is called testing data. So in most of your image processing or computer vision related application, or even for any neural network based application, there's something called training data on which you train your algorithm. Testing data or validation data comes in real time. Whenever you give a real time input and ask the algorithm to give the output, that goes under testing or validation. Then there is your object recognition. So on the left side, you might observe that a set of pliers is there, a knife is there.
ते पहिलं झिरो येईल ना
Okay, but you are not able to see the complete image.
फॅकल्टी
Here only
प्रोफेशनल
the
मध्ये
images are blacked out, but still we are able to recognize it. So recognition is not based on color of the object. Sometimes we might use the color information to determine that what is the object, but most of the time it is shape of that object. On the right hand side, you might see a three-button mouse in ancient time. Means when your technology was not that advanced, but still means the basic computer was present. So how to go for indexing in the data set? So you go for shape content. So at the bottom you can see what are the queries and what is the shape present. So if the shape looks something like a trouser or a plier with which you can match it. So a query object is there and intuitively you can say that this query object at top left side matches with that of the plier. Okay. So
त्याला करून
how it
घ्यायचं का
matches
मॅडम मग ते
some
स्कॉलरला
part of the
गुगल
plier,
स्कॉलरला
specifically the bottom part, if you rotate it, then it will match with the query image. Okay. Also, if you try to see that there are image of feet of kangaroo, they are also can match with it, but the nearest neighbor match or the maximum match is with the we can say grip of plier. Okay, so that is called shape indexing in the database. Also, multiple things like here we have that Google Lens. If you point it towards one object like one bottle, it will tell you that yes, where you can purchase that bottle of the same brand. Okay, so there all the indexing of that object needs to be present somewhere in the data set, somewhere in the cloud, and that uses your color as well as texture. Okay, so it might require some computation time. Like first you give a query image of let's say bathroom cleaner. The image is of very poor quality. It will try to find out what exactly matches with that. And if you observe there are two images which might contain similar features. So that's why two objects are found from the data set based on the color and texture. Here the color is used because that signature green, yellow and red combination, it tries to find out whether that is present in any of the images and then gives you the output. Then comes a very important part with respect to the defense perspective of target recognition. Like mostly if the surveillance is to be carried out at night time, you won't be able to see the color of object. You can have infrared imagery with you, but from the shape of object, one is able to recognize what exactly is present in that object. It's a very nice thing and specifically useful for your defense purposes. Then there is interpretation of your aerial photography. Like here you can see that some kind of hotel is there where cars are parked or boats are parked. So from image itself you should be able to recognize that yes, what all objects are present, what can be the tentative application of this. Like one example was the Pokhran. We had our first nuclear bomb testing at Pokhran. And if if someone already did the nuclear testing, he or she or that country knows that what all equipment, what all components will be required to set up the testing site. So we had that satellite imagery data which was available in multiple countries, and they were keeping a track on all parts of the world where any such testing is going on or not. So from satellite image itself, one can recognize that what all activities might be going on the ground. Then you have autonomous vehicles. This is one of the favorite topics for students for your technical festivals or competitions like flying follower robot or puzzle solving robot. So what do they use? They basically use sensors to determine whether any obstacle is there in front or not, or it can have a 2D or 3D map of the area which is present. It can also have your what underwater or also in space. Our best example is your Mars rovers. They are autonomous vehicles taking decisions on their own because we are not there to control them. We can give specific set of instructions that yes, you have to perform these tasks, but how to perform depending on the atmosphere, depending on the surface, they take decisions on their own. Right? So that is the kind of intelligence which is inbuilt. Then you have traffic monitoring system, again based on image processing based application, and some of you also can also try adaptive traffic signal. Like if at the signal, if the traffic is very high from a particular side, even if the timer for that particular side to be on the higher side as compared to other side, so as to remove the congestion. So there are dedicated softwares for that. But basic feed from a camera can also be used to determine how many objects are or how many cars are there waiting in the lane to cross the signal, or how is the flow of traffic coming from one part of the country. Best example is if you open Google Maps and if you put your address to go to a particular location, it will tell you that yes, there is congestion at particular location. And if you observe closely, those congestions are mostly at signals. It will tell you that yes, signals are the vehicles are stopped at a particular location. Now, one might say that it is not using mobile image processing data for that. So basically, it is using the GPS position of multiple smartphones, Android-based phones, which are present. If multiple phones are stopped at a particular location, the US algorithm will interpret that yes, there is some form of traffic jam. So at a signal, if multiple vehicles stop because of red light, it will be okay. Okay, and if no traffic is there, it will be represented by green color. But if you, the earlier vehicle data or smartphone shows that the vehicle has moved at a slower speed, or there were multiple vibrations on the road, it will tell you that yes, the road is not good, and it will represent in orange color. Okay, so all this monitoring can be done using GPS data, accelerometer, and also using image processing. Then you have your face detection. The basic algorithm that you can try for face recognition is VLA which is inbuilt available in MATLAB in the detector part, the vision detector object. Okay, so it uses simply it tries to find out where are the eyes, because eyes is the easiest thing to you can say determine in an image. Why? Because the pattern is fixed. That white color, then some black color, round in shape, and then again the white color. This pattern is same for each and every individual present, irrespective of their skin color, gender, height, width. So try to find out two eyes. Very easy using R transform. They do it, the VLA algorithm. And once you determine that yes, the distance between eyes is let's say 2 centimeters or 3 centimeters. So depending on this distance, the size of complete face can be guessed. Okay, so that is a face detection mechanism. And from that you can go for face recognition. Once you observe that yes, you crop the images, face images, and then try to match it with the template. During my PhD days, we had our face recognition system for biometric attendance. We have to go in front of that sensor, just show our face, and our attendance was marked. So for that, it first has had to extract the face and then go for recognition. So again, for that, your face, or not exactly face, but features corresponding to face needs to be stored in some form of data set. And then whenever a new query comes or validation or testing phase comes, you give that facial image to your data set and get the original um, get the data whether the face features are present in data set or not. Then comes facial expression recognition. Like you have a dedicated data set for that, which is having 5 expressions like happy, sad, angry, anxious, so or surprised. In the left side of the face, you can see that the person is showing expression of surprise. So how a surprise is interpreted by computer? The mouth is open, the eyes are wide open, eyebrows are pointing upward. Okay, so all these geometrical features can be can say a pointing vector to the expression of what we say some form of like it can be happiness, sadness. So all these features comprise of at least one of the emotion or no neutral phase is there. Even that is one form of emotion. Okay, so this thing is also possible in your computer vision. Then there comes space tracking. So one might say where is space? That's the thing. That if nothing is present, the algorithm should not give you a nearest neighbor match that yes, face if face is not there, what is the nearest thing? Because even in this image, you can observe that there are few parts of the image where white color is being followed by a black color, which represents our eyes, but that is not present here. So again, it will try to find out whether any face is there or not. If not there, it will give nil output, not that yes, the nearest neighbor match. Then there comes hand gesture recognition. This you might have seen that a few years ago there used to be TVs which used to recognize that yes, volume control channel up down command simply by hand gesture. Also, one very good application is the sign language translation or sign language recognition using image processing. A very good topic for research, specifically for human computer interaction. This is very much useful. Like you should definitely watch a TED talk by Pranav Mistry. He has integrated most of the things using hand gestures. So depending on the hand gestures, the algorithm interprets that is what the user wants and does the task. Then there is human activity recognition. Like this is also in your suspicious activity recognition that yes, if two people are walking and they are exchanging something, then yes, some object is being transferred from one person to another. So person zero, it is a periodic motion, but it is carrying object. Person one, periodic motion not carrying object, but the object has changed place. Means there is some suspicious activity which is going on. Okay, so this human activity recognition is possible provided you label everything properly. So if you observe the places are labeled by 0 or 1, person is labeled by a bounding box, and finally you have your object that is being carried by one person and another person. So at the bottom you can see blue color, red color, and green color. So these are the labels which are provided to determine what kind of activity is being going on. Then you have medical application. On this, I actually worked for skin cancer recognition using convolutional neural networks. So each skin cancer looks like it is having a particular characteristic which can be observed just from the images on the skin. So you just have to point your smartphone towards your skin where you find that some form of abnormality is there, and the algorithm will be able to tell you that yes, what exactly which kind of cancer is present. So by the way, in India we have 7 or 8 types of skin cancers which are prominently present in India because our country falls in the temperate zone. The temperature is very high. The skin radiation might affect the skin cells and lead to cancer. Okay, then you have morphing of images in which like you can morph the image, a human face, and morph it to become or look like a chimpanzee's face. Uh, Recently, last year itself, there was a debate that the morphing has reached such an accuracy that you can also there was a video of something, but that was a morphed image. But it was very difficult to know that whether the video is real or not because of morphing. Also, you can have inserting artificial objects into a scene. This is nowadays going on in AR, VR, artificial reality or virtual reality. That's all the applications that I have for you today. Okay, thank you. Any doubts from your side? I know it was more of a theoretical thing, but I only wanted to give you an introduction because going deep in any topic will lead to it's more of a research topic, including the mathematics results that yes, my algorithm performs better than others' algorithm. I think very few of you are interested in that. So for that, I'll list down that yes, my topics are image quality assessment, denoising, noise estimation. There, if you want a dedicated discussion, you can mail me or get in touch with me. But for introduction to multiple applications, I think this much is sufficient. Thank you. Queries from your side?
So, it was a wonderful session and a very informative session from your side, sir. And I'm sure that students are having some doubts and are curious with some of their questions. So, the, the mic is open for all. And if you are having any doubts, you can ask. So, sir. And also, the feedback link is being shared with you all. Please fill it as soon as possible. Thank you.
Yes, in the chat box I can see one query regarding, yeah, the camera resolution. One has said that yes, it has reached now 64 megapixel and 32 megapixel. Very, you can say it's a marketing gimmick because recently when Google launched its what we can say mobile phone, but with only 12 megapixel camera. So why are all the companies running behind that 64 megapixel or 108 megapixel camera? I'll give one small example for that. If you're viewing this session on, let's say, laptop or even on mobile phone, the resolution of your screen, most probably it is full HD. The resolution will be 1080 by 1920. So that amounts to around 2 million pixels. So on your screen there are only 2 million dots, but the images that you are taking from your mobile phone, they contain 64 million dots. So basically you are downsampling data to view it. So the 64 megapixel or 108 megapixels, they are basically not required unless you're creating it on a booster. So the advertising gimmick is that yes, we are giving a 108 megapixel camera, but along with that, why the cost increases? Because if it is a 108 megapixel sensor, you require a higher capacity processor to process that data, higher capacity processor to process, and larger memory to store it. And if you're requiring, we can say, higher capacity processor, its battery requirement will be also high. So everything goes on increasing proportionally. So even though there is no need of such a high resolution camera unless you are working in satellite imagery or medical imagery. Even in medical imagery, you won't require this many number of pixels. This is just like for advertisement or to tell that yes, my camera or certain brand company camera contains 108 million pixels. Basically, uh, in reality, you won't be able to use it ever. And also, if you check the setting by default, it is set to 16 megapixel. Unless you go in that raw mode or go in setting and change it to 64 megapixel, you won't be able to actually get that 64 megapixel image. One more query is there. Can we use machine learning algorithm for image denoising, and how this image denoise? Uh, Actually, this recently, 1 month back itself, I am also reviewer of multiple journals. So I received you can say manuscript which actually used neural network for denoising. But if you are having access to MATLAB, you can try one algorithm that is BM3D. I'll type it in chat box. This MATLAB code is readily available. Just check the results of this algorithm. This algorithm is of year 2007. We are currently in 2021. So a 14-year-old algorithm, you just check the results. That's the problem with the field of denoising. It is already super saturated. The results presented by algorithm 14 years back are still considered as benchmark. So even if we try to introduce machine learning based algorithms for denoising, the algorithm might work for certain set of images, but not all images. Okay, that's why it's whenever anyone comes towards me for research, I generally avoid giving denoising topic because it is very difficult to surpass an algorithm which was published 14 years back. Unless you are working in a specific topic, like yes, I will denoise only X-ray images. In that case, you can have upper hand using artificial intelligence also, or even statistics-based algorithms. Any other queries?
Okay. I think all the queries are now sorted. So, last but not the least, I would like to thank our special guest, Professor Vipin Kamble sir, who, despite his busy schedule, has found time to grace this session with his valuable knowledge. And I personally wanted to add that you talked about image processing that we are actually learning in signals and systems subject right now in second year. You talked about many to one mapping, and we are learning this topic in discrete mathematics. And you talked about calculus, algebra, probabilities and statistics, control theory, and many other such uh, what we can say topics. So all these, yeah, all these topics will help us in our future life. And you also discussed about the real world applications, which was a plus point for us, that came to understand the topics more easily. So, and you talked about the projects, various projects, which we can utilize in our final year and third year projects. So, uh, I would also like to thank Mrs. Sonal Patil ma'am for taking one more initiative resulting in the organization of this session. And I thank all the distinguished invitees present here who accepted our invitation and attended the session with utmost patience and attention. I hope all the students would have enjoyed the session and learned something new which can upgrade their knowledge. Thank you. Thank you very much.
मशीन इंटेलिजन्स बद्दल बोलायला नाही आवडत. पण त्यांनी छान सांगितलं सर, म्हणजे मुलांना बाकीचे सगळं पोरांच्या पॉईंट्स एकदम व्यवस्थित घेतलं त्यांनी. शेवटी सांगितलं ना किंवा तो दुसरा नाही म्हणजे तुम्हाला अंगणवाडीचे फॉर्म आहे मी थोडंसं मशीन इंटेलिजन्स बद्दल घ्यायला पाहिजे त्यांनी म्हणजे इमेज आणि मशीन इंटेलिजन्स कसं कोरिलेटेड आहे हे थोडंसं पुढे तुम्ही एक्सटेंड करता 10-15 मिनिट. बाकी चांगलं आहे पोरांच्या पॉईंट ऑफ व्ह्यू चांगलं आहे.
शेवटपर्यंत होते मुलं.
युट्यूबला पण छान
आता बंद करू का?
आणि त्याने मला तर याला पण म्हणजे लिंक केला बरोबर सब्जेक्ट की आम्ही एक्सपेक्ट करू